Imagine this. Your API is humming along, perfect in dev, staging, even most of production. Then 2 M hits, traffic spikes, and suddenly everything burns. Not a total meltdown, just this slow, agonizing crawl that eventually cascades into failures. Sound familiar? This isn't just about a slow API. It's about your reputation, your users' trust, and frankly, your sleep. Nobody wants to be on call for that kind of chaos. By the end of this video, you'll have a battle-tested playbook for diagnosing, debugging, and ultimately conquering those elusive, peak traffic API performance nightmares. We're going beyond the obvious here. The ghost in the machine. Why peak failures are so tricky. Okay, so you run your tests. Everything's green. Staging looks great. You push to production, and for 90% of the day, it's flawless. But then, during that brief, intense period of peak load, things just fall apart. What gives? The real problem is that these issues are often non-deterministic. They're race conditions, resource contention, or subtle deadlocks that only manifest when many users hit the same code path simultaneously. It's like trying to find a single grain of sand on a beach during a hurricane. Honestly, I think one of the biggest misconceptions is that if it works locally, it'll work everywhere. That's just naive. Your local machine isn't handling thousands of concurrent requests, nor is it dealing with network latency to a dozen downstream services. It's a different beast entirely. The usual suspects, where to first look for bottlenecks. When an API slows down, your immediate thought usually goes to the database. And honestly, you're often right. Slow queries, missing indexes, or just an overwhelming number of connections are prime culprits. But it's not always that simple. Then there are external services. Are you calling a third-party API that's suddenly throttling you? Or perhaps an internal microservice that's struggling under the same peak load? It's easy to forget that your API isn't an island. Real talk, I've spent hours debugging my code only to find out it was a downstream service. And finally, inefficient code. Maybe you're doing N+1 queries, or processing huge datasets in memory that should be streamed, or looping unnecessarily. It's the simplest stuff, but under pressure, simple, inefficient loops become catastrophic. Hot take, sometimes the most complex performance problems have the dumbest, simplest code fixes. Beyond the obvious, concurrency, limits, and resource starvation. Okay, so you've checked the usual suspects. What next? This is where it gets interesting. We're talking about things like database connection pool exhaustion. Your app might be trying to open too many connections or not closing them fast enough, leading to a backlog. Then there's thread pool starvation in your application server. If your server only has, say, 50 threads to handle requests and 51 requests come in, one has to wait. If many long-running requests hog those threads, new requests just pile up, leading to timeouts. It's a classic bottleneck that's hard to spot without proper monitoring. And here's a subtle one. Garbage collection pauses. If your application is creating a ton of short-lived objects under heavy load, the garbage collector might kick in more frequently, pausing your application threads and adding latency. This is particularly gnarly in languages like Java or Go. Quick side note, memory leaks can exacerbate this, making GC work overtime. Simulating reality, the art of load testing. You cannot fix what you cannot reliably reproduce. This is where proper load testing becomes your absolute best friend. Not just hitting an endpoint with a few requests, but simulating realistic user behavior and traffic patterns. Think concurrent users, ramp-up times, and varying request types. We've covered a lot, but here's where it gets really interesting. Understanding the tools and the mindset to not just fix, but prevent these peak traffic nightmares. Stick with me. The next steps are about turning theory into actionable strategy. This isn't just about hammering your API until it breaks. It's about finding the threshold. How many concurrent users or requests per second can it handle before latency spikes? Where does it start throwing errors? You need to push it past its breaking point, then back off and observe. Hot take. Many teams skip realistic load testing because it's too hard or too expensive. But the cost of a production outage from a preventable performance issue, that's way more expensive. Invest in tools like Case 6 or Locust. They're fantastic and often open source. And don't forget to test in an environment that closely mirrors production, not just your laptop. Smart scaling versus real optimization. When to scale, when to fix. So your API is slow at peak. Your first instinct might be to just throw more machines at it, right? Scale horizontally. More instances, problem solved. Sometimes, yes, that works. But often, if the bottleneck is a single database connection or shared resource, scaling horizontally just amplifies the problem. The key is to identify the actual bottleneck. Is it CPU, memory, network? If it's pure CPU crunching, scaling horizontally or vertically can help. But if it's waiting on a single database lock or an external API, you need to optimize that specific interaction, not just add more servers that also wait. Unpopular opinion. Sometimes the fix is actually not scaling, but simplifying. Removing unnecessary features, reducing payload sizes, or even just consolidating endpoints can have a bigger impact than adding 10 more servers. Complexity is the enemy of performance, especially at scale. Observability is your superpower, seeing beyond the logs. You know what's worse than a slow API? A slow API you can't get any data on. This is where robust observability comes in. We're talking about more than just basic logging. We need metrics, distributed tracing, and effective alerting. Without these, you're flying blind. Distributed tracing is especially critical for microservices. It lets you see the full journey of a request across multiple services, identifying exactly which service or even which function within a service is causing a slowdown. No more finger pointing between teams. And for the love of all that is holy, configure sensible alerts. Don't just alert on API is down. Alert on latency spikes, error rate increases, or connection pool exhaustion before it becomes a full outage. Proactive alerting is the difference between a minor incident and a full-blown emergency. Still with me? This stuff is critical. Advanced patterns and mindsets beyond a quick fix. Once you've nailed the basics, it's time to think about more advanced resilience patterns. Caching is your first line of defense against repeated, expensive operations. Implemented at multiple layers: client-side, CDN, API side, and even database side. Just be mindful of cache invalidation. That's where things get messy. Then there's rate limiting and circuit breakers. Rate limiting protects your API from being overwhelmed by a single client or malicious attack. Circuit breakers, on the other hand, prevent cascading failures by opening when a downstream service is struggling, giving it time to recover instead of hammering it repeatedly. Finally, embrace an asynchronous mindset. Long-running tasks shouldn't block your API threads. Offload them to message queues and process them in the background. Your API becomes snappier, more resilient, and can handle far more concurrent requests. It's a paradigm shift, but it's worth it. Go build something with this knowledge seriously. Let's recap. Peak traffic failures are often non-deterministic resource contention issues. Bottlenecks can be anywhere: database, external services, or inefficient code. Load testing in production-like environments is non-negotiable for finding issues. Smart optimization beats blind scaling when addressing fundamental bottlenecks. Comprehensive observability, metrics, traces, alerts is crucial for diagnosis and prevention. Advanced patterns like caching, rate limiting, and async processing build resilient systems. The key takeaways: always start by replicating the issue with realistic load tests. You can't fix what you can't see. Don't just add servers. Identify the true bottleneck: CPU, I/O, network, locks, and optimize there first. Invest in robust observability from day one. Metrics, tracing, and proactive alerts are your eyes and ears. Embrace resilience patterns like caching, circuit breakers, and asynchronous processing to build APIs that stand up to anything. Simplicity is a feature. Reduce complexity wherever possible to improve performance and maintainability. If this helped you understand something new about tackling those infuriating peak traffic API issues, consider supporting the channel. Every bit helps keep these videos free for everyone. Drop a comment with your thoughts on your worst API outage story.